Alright, so here's another solar build. Actually, this is a how-to video, how to build a garbage solar that can boil enough water to make soup. So it could probably be used for a lot of other things, distilling water and everything else, but the main mission is soup, so we have a couple of parameters there. So this is the first solar power that I made, first garbage one. I just threw it together really quick, cut everything out fast just to make sure that you could build it completely out of garbage. Use a chip wrapper, or chip bag, the inside to reflect the light. Just because I wanted to use garbage, actually tinfoil works way better. So in the next design we're going to use tinfoil. So with this, we're going to have to scale this up. I was not able to boil, this is a 500 milliliter container, I wasn't able to boil it with this size because everything's diffracted here and it's very crinkled. The light doesn't all make it to the thing, and also it's just not enough light. So this is our Mexican soup that we're going to try and make. It's just like a Mr. Noodle soup. It says you need 2 cups of water, so 500 milliliters of water. So this is all the stuff you need to build the next one. And on this side here, on the left side, is all the garbage that I found that I'm going to use to make this. So this is all the free stuff, and this is all the stuff that I had to buy. So let's start with the free stuff. Just like this solar here, all the structural stuff is made by thick cardboard, non-corrugated glued sheet cardboard. So that's a nice big sheet I found here as a garbage piece that we're going to use. So the main part here is an aerosol can. This is 400 milliliters. It should be good enough for soup instead of the 500 milliliters. You want something long and something skinny. This is about 1.5 inches, and it's 8 inches long. So this one was only 6 inches long, so we were stuck with the smaller size. So you want to spread out your water long, so you want a long aerosol can, or like a mousse for hair or something like that, something nice and skinny. Here I just found a board for a back support. This is just supported with cardboard, but the one we're going to build is a little bit bigger, so it's nice to get just a really nice straight piece. This part here that has the tinfoil reflective surface is just cereal boxes, so I have a couple cereal boxes here that I'm going to use for that side. Actually, this is supposed to go over there. That's on the bot side. That's about it. That's most of the building materials, major stuff that we're actually going to use. Now this stuff we just use a little bit of, or like this is a book where we're just going to need to write in, just some writing paper. We're just going to use a ruler. We're not actually going to like destroy it, or so we're not actually buying these things just for this build. So you need a ruler, scissors, a notebook, something to write on, aluminum paper. We're going to use some of that, aluminum foil, pencil, calculator to do the calculations for the parabolic curve. Then we have some just standard white glue and glue stick. So that's it. With all this, you should be able to boil water for food, and if you're living on the beach, which is actually why I got this idea. My friend is living on the beach. He has a couple friends that live on the beach, and they want to make soup and be able to cook with just the sunlight. They don't have to make fires. So yeah, I'm going to show you how to make something to boil 400 milliliters of water. Right, so the next step for me was to find out the dimensions, how big I'm going to make this. So I used a lot of the stuff that I have. So basically, I mean, this is 8.5 inches. So I'm going to use it 8.5 inches high, just like this was 6 inches, right? So it's going to be 8.5 inches high, and it's going to be 1 foot on each side, so 2 feet across. Now this thing's only 18 inches across, and it's not as high. So I did all the calculations and everything. It seems like this is going to be twice as much area as this one, but we're still going to try and boil the same amount of water. This one got up to 88 degrees Celsius, so it looks very good that we'll be able to do that, and it actually has similar power to the big solar device that I have. We're boiling less water, but it has the same amount of sun going into the water, so that one boils in half an hour. So we hopefully will get similar results. Then we use this equation here, and I'm going to calculate the curve I'm going to use. Also have to find out the focal height, so that's what this p-value is here. In this design I used 5, but I think I'm going to go a little higher. Probably use 6, and then yeah, 6 or 7. We should be ready to start cutting out and start assembling. Alright, so the next step I did was calculate the curve that I'm going to need, and this is actually something you don't really need to do. I mean, I'm going to be posting all the different curves you can have, so really you just have to pick a focal height and how wide it's going to be. Now, I've noticed over testing that this is good. 6, so actually here, I picked a focal of 6 inches. I think that's a good height. It'll give us a good curve for the width that we're going for 1 foot. And I've noticed that when the focal and the height at the end, so we want it to be 12 inches, all the way at the edge of 12 inches from the center, it'll be 6 as well. So I've noticed that it's a really good height if your farthest part is at about the same height as your focal. Now when you go further, it starts getting really steep and going up, and that's not good. So try and find out how much sun you want, how much energy you need. And so if it's 2 feet wide, then there's 1 foot on each side, and if you have 6 inches at the side with 6, that's good. Otherwise you might have to find another focal height and calculate what your end is, but we'll worry about that later. For now, I'm going to go with this setup. So I have a focal at 6 inches. Now I change this equation. I put 6 here as P because P is the focal, and then 4 times 6 is 24, so it's 1 over 24 x squared right there. There's the equation, and I use that to calculate all these points. So all I do is sub in x for here where x is. So I have 0 squared over 24 is 0. 1 squared over 24 is actually just 1 over 24, which comes out to 0.04. 2 squared is 4, so 4 over 24 is 0.166, and so on. And I calculate all the different points just by subbing in the new x value. Now these are all the points I'm going to have to graph in order to cut out the curve so that the parabola shape is right and all the sun hits the beam or whatever we're focusing off, which is this Glade cam. So I just did a little thing here. So I just did it. So I just said 1 block. I mean, these numbers are anything, but just have to be the same. They could all be feet. They could all be graph paper blocks. They could all be millimeters. Whatever size you need. But you just have to keep them the same. You can't have a focal in millimeters and you cut a curve in feet or something like that. So this is just, I'm just doing it by block. So you see at 1, so we go 1 over 1x, and then this is the y-axis going up. We go 0.04 up, so almost nothing. And then we go at 2, we go 0.166, so at 2, 0.166, a little bit higher, and so on and so forth. As we come out here, I mean for 4, we have 0.66, which is over half here, and then for 5, we have just over 1, so 5 is over 1 block, and 6 is 1.5, so 6 we have 1.5 blocks. So that's how you graph, and we're going to graph it right on the sheet here. We're just going to make all the points, and we're going to go by inches, so these are all going to be inches, and I'll just measure with my ruler and make the dots, and then we can make a curve and cut it out. So yeah, we're going to start doing that. We're going to start assembling. We've done all the design work so far, and yeah, we're free to actually make it. Alright, so my first build step is going to be to cut this curve out. So, I said I had a curve here. From this data, it says at 12 inches from the center, it's 6 inches high, so we have the height is 6. But also we need a little bit of material in the middle. I mean, if we just cut out 2 curves and they touch the bottom, then there won't be any cardboard here. So we need this for support. So I'm thinking, last design I used 2, but this is very long, so I mean 1, so this design I'm going to use 2. So with 2 inches in the center, that means I have to go 2 inches and then up 6. So this is 8 inches, and this is 24 for the full span of the device. So you know it's garbage because it has a nice tire mark right across it. Yeah, so I have my ruler and my pencil, and I'm going to mark out my 24 by 8 inch pieces. So I need 4 of them. So I'm just going to do that, and then I'm going to cut them out. So we have it marked off right here, 8 inches by 24 inches. And with this edge here, like it's okay if there's a rip here because we're cutting a curve out like this, and this all is going to get cut out. But here, this edge has to be extra straight. Like this really has to be straight because this is what's going to lie on the support in the back. And if you tilt it, then you have it go like this and like that, and all the sun is going to miss the can. So you need one long straight edge. This can be very tattered because you're going to recut another edge around. These doesn't really matter. They're not up against anything. It's just the back edge, especially the middle. The middle has to be nice and straight and represent the whole thing. Alright, so I started graphing my points on my calculator just to convert the fractions of an inch into real numbers. So like 1/8 and 3/16, just find out exactly what those are. In decimals, I'm not sure. So I'm using these, and I've graphed the first points up to 4. So I did 0, all these up to 4. So you can see all these little values are half and 0.3 and all that kind of stuff. So that's basically what I did here at 0, 0. So first of all, actually, because I need this strength in the middle to support the outsides, I move the line up and I measure exactly 2 inches up, and I make sure it's nice and straight, 2 inches all the way across, and I make sure that it's going to be angled to right here. Once I get my line here, I just go along and I measure every inch, and I number them 1, 2, 3, 4, 5, all the way to 12. So I did 0, and then the first one is 1, so I go 1 equals 0.04, and then I go up 0.04. So now I did that for all of them, and now we're at 5. So if we look at x equals 5, 0.014. So what I do is I put my ruler here nice and straight, right exactly at where the 5 is, and I look at 1. Basically I want is 1 and just a tiny bit. So I can find out what 0.04 is. It's the same as here. And I measured that, so that was about less than a 16th. Something like that. So I can go up and go 1, and I go less than a 16th. Put a dot right there. Perfect, so that's number 5. And you just keep going. You can see how it starts bending up, and probably at the end it should be about here in the corner, because it's going to be 6 inches up. We already calculated the last piece, 12 and 6. And you want a nice flowing curve. Now you'll notice, like if I had a dot here for 3, you'll notice that it doesn't follow a curve. You can't really go 1, 2, and then come up here, come back down. So if it's not in line, recheck the numbers to make sure that all the points are in line. Also, if you have a square, that's good. As you get to the higher numbers, you can line it up with 5 and make sure that it lines up on top, that you're not going over like that. And yeah, we only have to graph one of these. Once we cut it out, we can trace the shape onto the other 3 pieces. I'm done marking all the points, so what I'm going to do now is just make a constant curve. So basically just, it's like coloring, I guess. You just draw between the lines and just follow the curve. Makes sense, it matches them together. You don't have to be that exact, but I mean, you can just draw straight lines between them. That'll basically do the trick, but I like drawing just freehand curves, trying to keep a nice curve. And all that light reflecting on that pipe. There's my curve. You can see here, it gets pretty steep right here as it gets to the same height as the focal. Now if we keep going, it would just get really steep, and we'd have so much material, so much reflective surface, but really, because the sun area that we get is the direct here head on. So here you have more material, more reflective material, and you're getting less sun. And as you get in, you get more and more sun on a certain amount of material. So it's really not good to go past this height. So yeah, I'm going to trace it out on this side, and I'm going to cut this whole shape out, and that'll give me this piece here where we can bend our cereal boxes with. And I'm going to use this piece, line up the bottoms, and trace out onto the other pieces, cut those out. There it is, curves done on both sides. So I just put all the points and trace this one as well. So you have traced on both sides. Now this is a nice line where we can cut, so we just take scissors and we just cut along the line, and then we take this, and this we don't need, and we use the bottom for the device. We also use it to trace on the other one. So I'm going to do that now. I'm going to cut it out, and we'll keep going. So there you go, curves cut out. So now what I'm going to do is I'm going to cut out the other ones, but then I'm going to take this, line up the bottom, which is the most important, like I said, and then just hold it down and then trace this out, and then cut that one off the next one. You want to check that both the things you cut out, both the curves you cut out are good, and so this is where I was telling you how important the base is. This back one here has a little step in the base, so one side is lower than the other. So now when you put them two together, you see that there is a significant gap there, which causes the problem. There's a little bit of an overlap, but I mean, it's not that much of a problem. We have a pretty big cylinder, and it's pretty close to this, so you want it as close as possible, but not overboard. So it seems to work. I think I'm also going to try with just 2 supports. I just put them together, and it seems like they'd be way too crowded for 4. Also, my hand hurts from all the cutting with the scissors. It's thick material, and I'm running out of free good cardboard. So what I'm going to do is put a lot of supports between the 2 to make sure that they don't move too much. I might actually add some wood reinforcement. But yeah, we're going to go with 2 of these things, and it should be good. Alright, because I don't have the 4 pieces, I need a little more support, so I quickly cut out this thing. It's 5 inches by 24 inches, and what I'm going to do is I'm going to glue both of these on here with the white glue, and that's going to give us the support so it doesn't go side to side. It should really strengthen it up. They're going to turn into like a box. I'm also going to cut smaller pieces that are maybe a little bit smaller here, a little square to glue in to give it the rigidity. You go back and forth all before I cover it, which will give it even more strength. So then it'll be a nice solid piece and then that'll glue nicely onto this back. And also the localized bending here, just the place where it's mounted, won't matter as much because this is going to bridge over the gaps and everything and create more of a level piece. So I just taped this up quick, just to see what it's like when it's glued. I just have these supports up here to give it that, stop it from flopping back and forth. Line these up nice for the sheet later. So this is 4 inches apart. These are 4 inches wide. These are cubes I cut out, 4 inches by 4 inches. And they fit here quite nicely, and this bottom part is about 5 inches, 24 inches long. So this is going to give me that square-like rigidity. So I'm going to glue the bottom pieces here, the 2 bottom pieces, and then glue these together, and I'm going to tape it up so that they can dry nicely. I'm just going to use normal white glue, even though it's not good in the rain and everything else, but it's just the easiest for me, to easiest and cheapest. But you can really use anything. So yeah, that's going to be the shape, and then that is going to go on the backboard there. It's together here, and I put a bit of glue on it. So I have these bottles there to hold the shape and prevent it from falling. This one pushes this way to line it all up. Made sure this line was really definitely straight. How this so glue doesn't get on the table. But yeah, I have the supports here. I added an extra one here in the middle. Lots and lots of glue. And yeah, once this dries, it should be pretty solid, and then I can bend the sheet on top of it. So this is about 4 inches, and then I'll have about 2 inches of overhang on both sides, which will get pretty warped, but it should be okay. Here's a glue solar device. All the glue, white glue, is now transparent. It's all done, and it's really a nice rigid piece. So this is what I'm going to be doing, I think, from now on for all these really cheap ones, is put a nice piece on the bottom and turn it into like a box. Nice piece there. The only problem here is one of the angles here. That piece is a little bit off. It's pulling in, so I'm going to put a little V triangle there to hold that up. Other than that, they all look pretty good, and I'm going to sand this edge. So I have this piece of broomstick here, and I have a piece of 80 grit sandpaper attached to it, and I'm going to sand it up and down so that they match the 2 sides, get out all the bumps, and then we can glue the sheets on and the tinfoil and continue assembling. Sanding just makes sure these two, that both sides get sandpaper, and you just go up and down, and you just want to make sure that you don't want the one cardboard to be higher, which would give you an angle like this or an angle like that. You just want to make sure that it's nice and level when you sand it, and you're taking out all the bumps and everything from cutting it and the points to make sure it's a nice smooth curve. That's it. Glue another 4 by 4 inch square that I cut out just on the top here. So this is at the end of the curve at the point where it's not very strong. So just make sure it held together. Also on this side, one of them was bent pretty far. So here I'm just making sure that they're both together and one isn't bent in, which will change the curve a little bit, and that just gives that more strength. And other than that, I mean, everything seems very strong. And after this piece should be done. So I glued in the support squares. I put glue on this edge first, took it out, put glue on it on both sides, and then slid it in so you get nice contact, and then I just put an extra bead of glue around here. And I taped it, just some duct tape to make sure it held the sides in, so it pinches the sides to keep it together. Here too I had to put 2 pieces of tape, and there's glue all the way down both sides. So this really will give me that extra strength on the top. So I have my cereal box here, and what we have to do now is we have to cut it out. So we want 8.5 inches in width here, and as you curve it, it gets longer, so it's not really a foot here, it's a little bit longer. And usually I try and have the seam underneath because that's where the shadow is, and it makes the least amount of impact on the device. So what I'm trying to do is go from about the center up to the side like that, and we're going to bend it into shape. And then marked here, I'm just going to cut that out, and then I'm going to glue it with some weights on it and bend it into shape there. There it is, there's the one side. I'm just about to glue it now, so what I want to do is make sure the gap here is the same on both sides. I don't want it overhang. I mean, if I mounted it like this, then this would be really unstable and everything like that, but I do want to measure it just to make sure. You can almost do it by eye, I mean, just throw it on, but I'd rather measure it. So it's 8.5 inches across. It's supposed to be 4 inches, but it changes. So we're looking at somewhere about 2.25 inches on both sides. So that's what I'm going to try and do. I'm going to measure it, line it up, then I'm going to glue it. What you want to do is you want to put a nice layer of glue here on the cardboard, and then you can put the cereal box on top of that. Covered in glue. I'm ready to put the cereal box on, but when I do this I want to put it on, and I don't want to move it around too much. If I move it around it's going to smear all the glue, so I want the glue to stay there. I want quite a bit of glue so the thing holds really well. Alright, so I glued it. So when you do this, when you're gluing these things, you want to tilt up the whole thing. So I'm just gluing one side at a time, and you want this to almost be facing up. Now, I could have done a little bit better. It could have been like this, but you just want to do this so that all the weight pulls it down, and it's easier to glue. And now you want to put things on there to weight it down so that the two pieces are touching. You want to go around the whole length here and make sure that the cereal box is touching the structural cardboard all the way around. If you see a gap, that means you're going to get a bad angle. So you want to glue it all the way nice, have both sides touching. So if there's a gap somewhere, try and put more weight on it somewhere. Don't put too much weight to break it, but just small pieces of weight like this, the little pieces, the little glue bottles and everything like that, little things full of water. Nothing big like that, nothing like a liter, but you let that sit there and that should be good. Right, so I glued the other side on. I have lots of weight on this one. I want to make sure that it's perfect, and it looks like there's no gaps, so it looks nice. It's all centered. Just let that dry, and then we're closer on our way to boiling water. Next step will probably be aluminum foil. Yeah, I put a little too much glue there, which is no big deal. But yeah, there she is. Alright, there is this garbage solar device. So both sides are glued. Looks pretty good. It's very strong, so the center is very strong, the outside's pretty strong. It's the corners that are easy to bend. So you can put some reinforcement there. You could put like a little a triangle that comes out here or something. Also, where the two pieces meet, it's not as strong. And the corners as well, definitely not as strong. So those are the points you gotta watch. But other than that, it gets very strong. I mean, it's very thin material, but when you bend it, it really gets strong. So now I have to cover it with tinfoil. We're ready to start tinfoiling. So when I get a nice piece of tinfoil, this is pretty crinkly, but that happens.